The science of remote sensing embraces a range of techniques to observe and record data around the Earth's surface. The most valuable application of this technology has been in the identification and management of our natural and renewable resources. Modern society has an insatiable appetite for timely and accurate information in fields as widespread as environmental monitoring, agricultural management, weather forecasting, urban and regional planning, and mineral exploration. Australia has capitalised on the benefits of remote sensing. Earth-orbiting satellites provide information nationally and on a daily basis, expanding our understanding of the land, oceans, and atmosphere. Essentially, remote sensing consists of two elements: the spaceborne or airborne sensors which collect and transmit data, and the ground-based systems for receiving and analysing these. It is in this second area of data validation and application technology that Australia has developed leading-edge expertise. Data reception and processing centres have been established by the Commonwealth and several state governments. Our remote sensing community is diverse, producing both innovative research and value-added data interpretation, as well as developing specialist application hardware and software. Australia routinely acquires remote sense data from a number of satellites, including the US Landsat and NOAA, the French SPOT, Europe's ERS-1, and Japan's GMS. The information from these is received and processed primarily by ACRES, the Australian Centre for Remote Sensing. In this facility, recent upgrades to handle rapid data transmission from new generation satellites have included the installation of Ethers, an Australian-designed and built supercomputer capable of processing radar data in 1/10 of real time. This means it is able to process the information gathered during one orbit in the duration of that orbit. It is one of the world's most powerful supercomputers of its type, ideally suited to situations where immediate information is essential. Ethers is being marketed internationally under licence to the Australian Space Office. The data Ethers processes is supplied by the Synthetic Aperture Radar, or SAR, flown on Europe's ERS-1 satellite. The SAR generates its radar signals from a 100 kilometre by 4 kilometre footprint. It provides imaging data day or night and is unaffected by surface conditions, penetrating both cloud cover and vegetation. A key area where remote sense data is used with increasing efficiency is the rural sector, enhancing competitiveness while improving overall land management practices. Landsat is used in mapping and agricultural management, providing farmers with essential information to improve farming techniques. Environmental degradation through grazing and the effect of wind erosion can be analysed seasonally. As well as this, software packages have been designed to map grazing patterns and fodder availability. Crop inventory management and yield forecasting can be planned more accurately. Potential ecological threats such as salinity, crop stress and disease, and the control of pests are more accurately monitored and therefore reduced. Surveillance of unwanted crops such as weeds are also enhanced by satellite data. Illegal cropping and irrigation practices, as well as agricultural dispute settling, are other areas where remote sensing is being employed more frequently. The coastal regions of Australia have an abundance of tropical crops such as sugar, rice, bananas and pineapples. Our experience in remote sensing with such a diversity of crops has provided many export opportunities for our interpretation expertise and our value-added software programs. These systems have provided a monitoring accuracy of around 98%, proving remote sensing to be less expensive in many cases than conventional aerial photography. A major obstacle to the solution of many problems is often the immense scale of the areas affected. Satellite imagery provides a cost-effective solution to this problem. Frequently, satellite imagery is combined with ground-based data to create a Geographic Information System, or GIS. Digital satellite data is ideally suited to form the basis of a GIS, where it is layered with conventional data relating to vegetation, geology and topography to form a structured, coordinated database. Accurate monitoring of change over time has long been recognised as critical to successful environmental control. The information in a GIS is upgraded constantly and can be rapidly accessed and interrogated to provide the basis for informed decision-making. Australia, like many island nations, depends heavily on its surrounding oceans. They provide a means of transportation, play a significant role in determining the climate, and support vital fishing industries. Dynamic studies using satellite imagery are currently underway, mapping various water masses and their properties around our coastline. The West Australian fishing industry is one example, where it has been found that bluefin tuna congregate near the boundary of the warm Leeuwin Current and the cooler waters of the Southern Ocean. Processed NOAA imagery has been used to assist in locating fishing catches, while the technological improvement in data from instruments such as the Advanced Very High Resolution Radiometer on Japan's GMS system and the Long Track Scanning Radiometer, or ATSR, on Europe's ERS-1 has meant more detailed studies are underway mapping and identifying current zones, shelf topography and swell patterns. The ATSR is an instrument for measuring sea surface temperature to an accuracy of 0.3 degrees Celsius. The prime purpose of the device is the monitoring of long-term global climate change. Some 14 Australian principal investigators with 19 separate experiments are participating in the ERS-1 science program. Sea surface temperatures have a significant impact on fish breeding patterns, which can also be monitored by the ATSR. But fishing is not the only seaborne activity to benefit from remote sensing. Because of the high horizontal velocities of ocean currents and the variations in wind speed and wave heights, commercial shipping operations need regular, accurate information. This data is provided by the radar scatterometers and altimeters on spacecraft. There is no doubt that the Australian climate, which ranges from tropical to subantarctic, has provided an ideal laboratory in which to apply remote sensing to the practical solution of problems. As well as environmental and agricultural uses, remote sensing provides many benefits to other areas. Commercial operators in Australia's mining and extractive industries were quick to recognise the benefits such large area coverage allowed, with the potential to increase overall efficiency and profitability. Skilled interpreters have developed techniques for examining exploration satellite data and using this as a geographic basis for comparison with conventional ground and airborne information. Strategic monitoring is another area where remote sensing has been quickly accepted. The path of a tropical cyclone can be plotted hour by hour, well before its arrival on our shores. Authorities involved in bushfire or major disaster risk assessment have access to time-critical intelligence. The detection of illegal shipping, the monitoring of fishing activities, and the management of coastal pollution are all enhanced by accurate, timely information. Remote sensing activities provide enormous benefit to both public and private enterprises. They supply timely, uniform data that is computer compatible and can be merged from other sources to form a geographic information system. The currency of the information received means that it is very suitable for use by a diversity of organisations. Within Australia, distribution networks are already in place with specialist consultants in many fields and disciplines. Our software and hardware designers have produced application-specific products catering for exact needs, and these are constantly being expanded. Major education and training institutions now provide remote sensing tuition, and in the field, services are available for all levels of user. Remote sensing plays a prominent and key role in the mapping and management of the Australian continent, and our ongoing involvement in international remote sensing satellite programs has meant a rapid transfer of information to the user community. We invite you to join with us now to embrace these new and improved technologies which are revolutionising all fields of environmental management.